Okay. Acha, let's see. Respond from time to time. Okay. I will need your response. Can you see the screen?
Yes, sir.
Yes, sir.
See. Okay. So I have already provided you with this presentation PPT. You will find it there. Let's see. Acha. Now, how many do you recognize this guy? Raise your hand. না তো এখন ক্লাসে তো raise your hand ও করা যাচ্ছে না. How many? Someone mention.
Oh, they
Follow.
match.
Acha, 201. Yes. So some of you
Yes.
know this guy. There are some of you who don't know this guy, right? Now, you see the whole idea of this one, knowing this guy, comes from your previous, you can say, knowledge or experience. Okay. So this is like a visual expression. You have seen something, that's why you know it. If you have not seen him earlier, you don't know who that is. Acha. So let's see. Look at these two images. Both are penguins. Left side is one of the breed that's called emperor penguin. The right side is another one called the macaroni penguin. Why it is called acha? The emperor penguin has some specific like features. You can see there are some in this region there is some yellow or orangish color. In the macaroni penguins, you can see they are like macaroni. Okay. Towards the head. So that's why they actually got this name. Now, you probably have seen this type of breeds, but did not know the name of these different types of penguins. But now you know. So this is what is look like an emperor penguin. This is what looks like a macaroni penguin. Now let me ask you a question. Look at this. Is this a penguin?
Yes, sir.
Yes, it is a penguin. Can you say what is the species? Name of this
No,
species?
sir.
Some type of penguin. But is it the previous two, emperor or macaroni?
No, sir.
No. Why?
Because they look different.
They look different. Yes. So basically, you see, whenever you are seeing these things inside your head, there is a kind of pattern recognition software installed. Okay. So by your creator. So basically, we automatically understand some patterns, identify some patterns, that these are the patterns that makes it an emperor penguin. These are the patterns that makes it a macaroni penguin. And when you look at it, we don't see those patterns here in this type. Okay. So this has a different name. This is called chin strap penguin, because you can see around its chin there is a long scale. So this is called a chin strap penguin. Okay. Another breed. 3 different types of breed. So now you know. So once you know, then you can recognize other types of penguins. For instance, if I give you this one, can you tell me what is the breed among the 3 types?
Emperor.
Emperor. Yes, this is the emperor types, because you can see, you have seen some of the patterns that actually looks like this. So basically, you see what we are doing, what we have done so far. I have given you an image. You quickly identify some patterns, then you are able to distinguish from one class from another. Okay. So that is see, you see there are some distinguishable features in each variation of the penguin, and you are, as human, we are very excellent at finding those patterns. Okay, this is how we are actually learning. That's how human learns. Now, the same thing, we want our AI to do it. Okay. Just like we can actually identify very quickly that this is emperor penguin, this is a chin strap penguin. Now, what about them? Does it look like any of them?
No, sir.
No, sir.
Somewhat close to chin strap, I would say, but not the chin. So it does not look any of them. So basically, we want our AI to identify the same thing. Okay, whatever we have done, we want our AI to do this. But there is a catch. You see, this is visual information. Visual information means like an image or video. And this is like a sort of unstructured data. Okay, and we want our computers to make sense of that data. And these things, like it is not achievable through manual programming. How manual programming? For instance, previously when we worked with structured data, we had things like diabetes positive. Why diabetes positive? Because some of the test results were like this. the patient has high BMI or family history of diabetes. We understand those features. Those has meaning to us. But when it came to like this kind of visual information, okay, like an image, those features are not apparent to us. আমি কি বোঝাতে পারতেছি? ফিচারগুলো আমাদের কাছে অ্যাপারেন্ট না, সো দ্য ফিচার্স আর নট অ্যাপারেন্ট। ওকে, দিস ফিচার্স আর নট directly available to us. So basically, manual programming like decision tree is no longer possible here. So we have to do something different. So that's where machine learning comes in. We want our AI to capture those patterns somehow. Somehow we want our AI to capture those patterns as well. And we'll see how it can be done. Acha. Any question up to now? Okay, let's move on. Now, look at this one. This is on the left side. This is a panda. Now, this one, again, this is a penguin. Acha. So, how do we differentiate a panda from a penguin? Both have white and black color, like patterns have white and black, but we are distinguishing one from another. See, we can see there is it has a vertical shape. Okay, the transition from black to white is like a vertical, but this is circular or round shapes. Okay, so what you are actually seeing here is some kind of shape or orientation, how they are actually how they are created. So looking at this orientation, like for instance, you can see these ears. They have two pointy ears, but circular ears. But for the penguin, they don't have those ears. Again, the penguin has a beak, very long beak. Panda does not have that beak. So this kind of things, this is what actually help us identify one species from another. And we want something similar for the AI. We want the AI to identify these patterns. What makes this one different from that one? Okay, so this is how we are going to see how it is done. Any question up to now? So in the last class, lecture 25, that means the next class, when we actually saw CNN, we have already studied. In CNN, we have seen how using convolutional architecture, we can identify loopy pattern, vertical pattern, horizontal pattern. Okay, similar to these things, when we actually have this hierarchical learning in CNN, we can actually identify all sorts of pattern. Based on those patterns, we can actually classify. Okay, so let's see. Computer vision is a field in artificial intelligence AI that enables computers to interpret and analyze visual information, okay, from images and videos. Okay, acha. Traditional machine learning algorithms cannot extract the patterns like this. Okay, so we need deep learning algorithms. So among the deep learning algorithms, the most popular one that we have is called convolutional neural network. We have seen in the next class, in the last class. So a convolutional neural network looks like this. You have this feature extraction part and you have this classification block. We talked about this in the last class. So this feature extraction part is basically extracting the features because we do not have the features directly available. Since we do not have the features available directly from the images, somehow we have to extract the features. Okay, we'll feed lots of images data and the algorithm will extract the features from it through this convolution operation. Then we perform the classification task. Acha. So basically এটাই আমি একটু বললাম। Now computer vision has many applications, okay, spanning from healthcare. For instance, when you go for like if you have a eye problem, okay, when you go visit an eye doctor, so when he checks your eye through a machine, the machine automatically suggests whether you have some particular disease or not, okay. Or when you are looking at a X-ray or MRI, okay, whenever you're doing those things, the computer, or it is called a computer-aided diagnosis system or CAD system, it already provides a suggestion, okay, to the doctor that, okay, I have identified this issue in the patients, or I did not identify, I don't see any issues in the patients. So in healthcare, computer vision is used in many different applications, okay. Yeah, there is an article provided from online sources. Try to study those things, study that article. You will find some of how computer vision is applied in different areas that is actually mentioned there. Acha. Now, in this class, we will try to identify, understand these application areas. Some of the application areas, let's see. Acha. First of all, image classification. This is a very common task. Image classification means classify image or label the image based on what is the category. So this is your dog, this is a cat. Distinguish between different types. So you want your AI to identify or say that this is the image of a cat and this is the image of a dog. So how do you do that? So how do you do this? Similarly, we actually feed lots of images of cats and dogs. Okay. During the training process, okay, the machine learning algorithm, and here we have the deep learning algorithm, will extract some patterns from these images of cats, from these images of dogs, that actually make this dog a dog, not a cat. Also, the features that makes this cat a cat, not a dog. For instance, the presence of whiskers. You see, the cat has long whiskers, but that feature will not be present in a dog. So this is one thing. Similarly, like this way, there are different patterns. Okay. For instance, pointy ears. Cats usually have pointy ears. Dogs do not have pointy ears. So things like this actually help us identify one from another. So these are the features that has been learned by deep learning. We don't exactly know what are the features based on which deep learning is making this decision, but the features are there. Okay, based on this, the deep learning will actually process this task. Now, these two species, these are actually very difficult for you to identify because most of you may not have seen this test. Can you tell me what left or right? What is the name of this species? Animals? Anyone?
Sir,
রাইটেরটা
armadillo.
মনে হয় আর্মাডিলো, নট শিওর তো।
ডান পাশেরটা?
Armadillo, sir.
আর্মাডিলো হইতে পারে।
হ্যাঁ হ্যাঁ, ওরকমই similar species. আচ্ছা, so this one is a kind of a deer, you can say. This is called antelope. So see, the difference is you don't know the species name because you have not seen it before. So think of it like from the perspective of AI. To make the AI recognize a species, you have to feed him lots of images. Then he can actually understand what makes it that particular species. So we human beings are capturing like this. So that's what we actually do. So when you're actually feeding the data, we actually feed lots of different types or categories. And based on that, we take a probability, or can say. So for instance, this image, okay, the AI is saying that the dog is 96% chance that it is a dog, 29% chance that this is a cat, 2% duck, 0% bird. So if I give you this, so can you tell me how many different categories of data we have fed the AI? কয়টা ক্লাস আমরা ফিট করছিলাম?
Sir, 4.
4. Yes, 4. That's why you have this 4 probability. So basically, when it comes to deep learning, you are going to predict probability for each class. Then whatever is the highest one, we are going to take that one. It's a little bit different than like decision tree. Okay, when it comes to deep learning, you will try to find the similarity. How much similar this is with dog, how much similar it is cat, then the other species. Then you say the one that is the highest, you say this is that. Okay, and you see dog means 36%. That means it is finding, the AI is finding 36% similarity with a dog. So because they are like similar elements, some of the patterns actually match. আচ্ছা, now one of the thing you see, some of these ones, these are very rare species. Like you probably have not heard the name of most of them. আমি নিজে কখনো শিখি নাই. Octopus, I know this one at least. I don't know the other ones. So basically, you see, one of the major challenge in deep learning is that rare species can be very difficult to learn. Why? Because you don't have that much data available. Okay. So you can barely collect some of the data for this one. You may have 10 images or 15 images, but very difficult to identify. But you see, the deep learning algorithms are very data hungry. Data hungry means they actually require a lot of images to distinguish patterns. So if you have a very good classification task for cat versus dog, you need to feed good amount of images. To give you an example, there is a in my GitHub, you will find one of the notebook. You will see there is a data set, cat versus dog data set with 2000 images. With this 2000 images, when you try to train, the accuracy is like 85% or 80%. So see, even with 4000 images of cats and dogs, the accuracy is not 100% still. Okay, so learning from images takes lots of data. Okay, so deep learning algorithms are very data hungry. It will take a lot of data to actually properly learn patterns. Okay, acha, any question up to now? Any question? Okay. Now CNN algorithms. We have talked about CNN in the last class. So there are different CNN algorithms. The first one was Linet. Okay, that actually came in 1998. The task that was used for Linet was human handwritten digit classification, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 types, 10 class. Okay, that's a very simple task, but that was the first time CNN was introduced. The idea of convolution operation was introduced. Okay, that was very old, 1998, but at that time the processing power was very limited. Okay, our computers did not have enough processing power, so it did not get much traction at that time. But gradually, as we have more better CPUs and especially GPUs, when okay, after the invention of GPUs, then everything actually took actually really started actually evaluation started. So in 2012, AlexNet, it won the ImageNet competition. ImageNet competition is a worldwide competition, very large. There was like 1,000 category with more than 100 million images. Okay, learning from that many images, okay, on that many categories is very difficult. And the CNN architecture that was based on the name of the researcher, Alex. This name is given AlexNet architecture. That AlexNet architecture actually performed exceptionally well, almost 10 to 15% higher than conventional image processing techniques. Okay, so that's when the idea of deep learning actually took leap. Okay. And from then, there has been a significant progress in this area. So you see VGGNet, GoogleNet or Inception based on the movies Inception, ResNet, DensNet. So you can see from in the last decade, mainly 2012 to 2019, the different CNN architecture has been produced and they have been actually working very well. Acha. Now, another application is called object detection. Acha. What is object detection? You can see detects object and their location in the image, surrounding the image with a bounding box. It is used in autonomous vehicle and surveillance. Let's see. So you see in this application, the task of classification was classifying it as a dog or a human being or a cat like this. In object detection, first you have to find the location of the object. So this is where the dog is located. Then classify it. So two tasks, not just classification, but also identification. And you surround it using a like a boundary. Okay. So this is like a bounding box here. So this is a car, this is a traffic light. You can see this is signs. So different bounding box. So there are two tasks here. So this is a more, it will take more time than simple classification. So you can see this is the localization, then classification. Achha. So this is what object detection actually looks like. Let's see. Now, when it comes to the bounding box, you can see there can be multiple bounding box. This is one, the blue one, this is one, and the green one is the best. Okay. So object detection is a little bit more time consuming because of this one, because you have to completely surround the object within a bounding box. Okay. So we do this by using a sliding window technique. We take a bounding box of size like this, slide it through the images one by one, okay, and try to ensure that whether the object is completely within the bounding box or not. Then we increase the size of the bounding box and then move on like this. Achha. Let me. So what we do here, let me elaborate a little bit on this. So let's say this is where your object is located. Some kind of object is here. Okay. So basically what we do, we start with a binding box of size this. Object আছে? নাই. Then go like this, like this, like this. তারপর নিচে, 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 নিচে. Some portion of the object is here, but not the entire portion. Again, some portion is there, not the entire portion, not the entire portion. Okay. So this is like one round of bounding box. We have tested, we have found the object in some of the 1, 2, 3, 4, 4টা পাইছি, but not the entire object. So what do we do in the next step? We increase the size of the bounding box. Okay. 1টা, 2টা, 3টা like this. 1টা, 2টা, 3টা. And in this one, we actually found the completely surrounded object. So it goes like this way. We have to use like the sliding window, like the sliding window technique. different size of bounding boxes, box. We will use different size of bounding boxes to actually obtain that one. Okay. Any question about this one? কারো কোনো question? Okay, let's see. So you can see there can be many possible boxes. So identify the perfect box is a bit like complicated task, more time consuming. Okay. So this is what classification, simple classification. This is what object detection. Okay, this is this. And the algorithms, object detection, you have to remember the names. Okay, you don't have to remember the details of the algorithms, but the names should be remembered. Okay, so for object detection algorithm, there are two types. One is called two-stage, another is called one-stage. Two-stages are more accurate, one-stages are more fast. Okay, and the most popular of them is YOLO. You probably have heard the name YOLO. That stands for you only loop once. So this is the most popular algorithm for object detection. Now we have version 12, I think. There are different versions of YOLO algorithm, and now you have version 3, 4, 5, 6, 7 এভাবে চলতেই আছে। আচ্ছা, another type is called image segmentation. আচ্ছা, what is image segmentation? There are three types: semantic or instance. Let's see. This is what a classification looks like. This is what the detection looks like. Location. Segmentation is this. Can you tell me what is the difference between detection and segmentation? Anyone?
স্যার সেগমেন্টেশনে শুধু ওই অবজেক্টটাই থাকবে, আশেপাশের কিছু নেবেন না এরকম কিছু।
Object এই
So
থাকবে,
I think
না, not exactly.
segmentation is like maybe trying to
Trying to
give a difference between the image and the background or something like that.
image and the background. Yeah, somewhere close. Basically,
এজ ডিটেকশন করছে, সেগমেন্টেশন আমরা এজ ডিটেকশন করছি।
age detection, yes, you can think of it like this way. Age detection is available. আচ্ছা,
সেগমেন্টেশনে স্যার মানে অবজেক্টের প্রতিটা পার্ট স্যার একদম অ্যাকুরেটলি ডিটেক্ট করে। ডিটেকশনে স্যার মনে করেন স্যার আশেপাশে একটু ব্যাকগ্রাউন্ড স্যার নেয়, মানে সেগমেন্টেশন
Yes.
স্যার মানে একদম অ্যাকুরেসি খুবই বেশি ডিটেকশনের থেকে এটাই আর কি স্যার।
Yes, yeah, ঠিক আছে. So in other words, that is actually segmentation is pixel wise detection. Okay, segmentation is pixel wise detection. You identify each pixel, whether the pixel belongs to this class or not. So you identify every pixel that belongs to this one. Then you say exactly the location. So you actually mark the edge. The previous one of you actually said you mark the edge of the object clearly. Okay, that's what segmentation is. In bounding box, there are some areas that may not be within the they are not actually with for this object, but in segmentation, it is much more critical. You want the exact boundary of the object. Okay, exact boundary, and actually mark pixel wise whatever the position is. So this is what segmentation actually looks like. Let's see. So this is your classification and localization. This is your object detection, and this is your segmentation. And this particular type is called instance segmentation. You are identifying every instance of the object. Okay, so this is the object. You see in the bounding box, there are overlapping boxes, but in instance segmentation, there is no overlap. You have to identify the exact position of the object clearly. Okay, so the task is more complicated or more simple? Complicated or simple?
কমপ্লিকেটেড।
Yes, it gets more complicated. Acha. Now,
Yeah.
another type of segmentation. Yes.
স্যার ক্লাসিফিকেশন প্লাস লোকালাইজেশন আর অবজেক্ট ডিটেকশনের ডিফারেন্স কি?
আচ্ছা, মানে ক্লাসিফিকেশন প্লাস লোকালাইজেশনটাই হচ্ছে অবজেক্ট ডিটেকশন বেসিক্যালি।
আচ্ছা,
ঠিক আছে, লোকালাইজেশনটা
Yes.
কি অবজেক্ট ডিটেকশন। লোকালাইজেশন হচ্ছে অবস্থান থেকে না, অবজেক্ট ডিটেকশন হচ্ছে এক্স্যাক্টলি বাউন্ডিং বক্স দিয়ে ইয়া করে দেওয়া। আচ্ছা, সমস্যা নাই। Now, there are two types of segmentation we have seen. This is instance segmentation, like I said, identifying the object. So this is the dog, cat. This is the object. Semantic segmentation is a little bit different. So it tries to, like, every pixel of the image, it tries to classify into different criteria. So for instance, this is dog, this is cat, this is tree, this is a sky. In instance, you focus on the object. In semantic segmentation, you focus on the entire image. Every bit of pixel should have a category. Okay, let's look at another example. Semantic segmentation classifies each pixel in an image. Road, sky, building, everything will be classified. Does not distinguish between different objects. So FCN architecture, let's see. See, in the images, these are cars, but when it comes to semantic segmentation, you mark every one of this. This is the car, this is the road, this is the sidewalk, these are the buildings. You mark every pixel with a particular category. So this is what semantic segmentation looks like. Okay. And in instance segmentation, you can see you are only focusing on the objects. Okay, these are the 4 objects. So that's what instance segmentation is. Acha. Okay, the same thing again. So in instance segmentation, you detect multiple objects from the same class separately. Okay. Acha. Now, question application. So for instance, autonomous driving, medical image analysis, satellite imagery. Now, if I ask you this question, which one is more important for semantic segmentation? Among these 5 applications, which one is used for semantic segmentation use in which application?
Autonomous driving.
Autonomous driving, yes, that is one thing. Why autonomous driving is semantic segmentation বেশি important compared to instance?
Because it gives information about environment too.
So you have to identify, have the whole idea of the area, right? So when you are doing autonomous driving, you should have a good idea of the area. So that's why semantic segmentation is important. আচ্ছা, এখানে আরেকটা বলো, আর কি হতে পারে?
Scene understanding.
Scene understanding. That is particularly for semantic segmentation. In a scene understanding, you want to understand everything that is present in the scene. Okay, so instance segmentation is not applicable here. So try to understand for which application which is more important. Okay, এটা একবার দেখে নিবা, নিজে একটু ঘেটে দেখে নিও। আচ্ছা, for instance, in medical image, why this is more important? You see, let's say tumor is in the brain. Now, এখানে কি আমাদের can we use object detection algorithm here? এটা যদি আমরা বাউন্ডিং বক্স, if we use a bounding box here, তাহলে কি কাজ করবে? Will it work? কাজ
No.
করবে?
No, sir. We need to
Why
identify
not?
every places where the tumor has grown.
Yes, you see, the size of the tumor is extremely important. So if you use a bounding box, you're not actually looking at the exact area or shape. No, you are just trying to identify the location. But when it comes to segmentation, you focus on the exact pixel-wise difference, that this is the exact area. So same in segmentation task is widely applicable in medical image analysis, especially the UNet architecture, to exactly identify where the tumor is located, what is the area of the tumor, what is the size of the tumor, to identify into different categories. So in those areas, segmentation is widely applicable. Okay, billions of dollars of research actually put into this kind of applications. Okay. Acha. Now, next. Acha. Now, object tracking. So far we have talked about mainly images. Now it also applicable to videos as well. Like a continuous video, you want to track a vehicle, like in a police chase, okay, or in a football match, you want to track the football where it is going exactly. So throughout the video, you want to track an object. So there are different algorithms to do this for that ones. And for instance, autonomous vehicle, if you have a car that is actually moving in front of you, you want to continuously track that car. Okay, to actually automatically the autonomous vehicle, the AI wants to automatically track that car all the time. So how it is moving, what is the speed change? Based on that, it needs to make a decision. So autonomous vehicle is one of the very complex application, but very powerful and engineering marvel, you can say. Acha, some of the algorithms, okay, you can no need to for that. Neural style transfer. This is another. So neural style transfer, it is interesting because most of you actually already, I think in Facebook, there is very common now. You want to change the style of the image. So you have a photo of a city, then you see the Van Gogh painting style and change it like this. For instance, this, look at this. So you have the image of the cat. Then this is the style. So you're taking the style from this painting and placing it here. So just like you are Ghibli painting, things like that you are using in Facebook. So this is called neural style transfer. So basically you have here two sorts of images. Okay, one is giving you the content, one CNN. Another CNN is giving you the style. Okay, so from one image, okay, you are taking the structure from the content. So এই image থেকে আমি content নিচ্ছি. Okay, and from this image I am taking the style. Okay, the textures or the crush colors like this, and then actually adding this together, joining this together into one new image. So this is called neural style transfer, transferring the style from one image to another. So let's say making a morning image into an evening image, things like this. So this is called neural style transfer, and there are different algorithms for this one. Acha. Any question up to now? Okay. Facial recognition. This is a very common application. For instance, nowadays, your smartphone has facial unlock feature. Most of the smartphone actually, some of the smartphone. So basically, what it is doing, you save your image from one, then the next time your camera is actually identifying that one person. Also, gate security. In a gate security, like there is a CCTV camera, it is automatically, whenever you're trying to interact with the gate, it is automatically capturing your face position and identifying who you are. Now, this is used in surveillance. In surveillance, first this is the object tracking, then identifying the position, then location, then the face. So three tasks. Now, this gets a little bit more interesting. Why so? Let's see. Now, previously, when we were designing our cat versus dog algorithm, okay, classifier, cat versus dog classifier, I told you that we have to feed like 1,000, 2,000 images to identify what a cat looks like or what a dog looks like. But in this particular example, you see, you have only one image, just one image. Okay, like in facial recognition, you are just giving one image. And from this one image, you have to just identify who that person is, whether the person is matched or not. So like this one, you have thousands of images of human beings' face, and just from even from these thousands and thousands of images, you have to match it. So the task is very complicated, right? আমার কথা কি বোঝা গেছে?
স্যার আরেকবার রিপিট করা যাবে?
So basically, when it comes to facial recognition, you see, when it was image classification, you have a cat versus dog classifier. So you are feeding hundreds and thousands of images to train the algorithm to learn this is the image of a cat, this is the image of a dog, right? But when it comes to this one, you see facial recognition. In the database, you only have one image. Like for instance, in the IT database, you have only one image of you. But whenever you are passed through the CCTV camera, from that one image, the AI need to identify who is that person, who is that student, or who is this faculty member from just one image. So it's like from a one image, you have to identify or match that person. Isn't it a little bit very difficult compared to the what we have learned previously? আমার কথা বোঝা গেছে?
Yes, sir.
So in social media tagging, you have automatic tagging in Facebook right now, nowadays. So basically, this task is a little bit different than previous one. So how we do it? So face detection. First, your task is to detect the face. You need the face. Then you align it. Then extract the face. There are some algorithms like FaceNet. Acha. Then face matching. So this is where it actually gets a little bit different. How so? Let's see. আচ্ছা এটা একটু in classification, okay, we have class, cat, dog, like 2,000 image like this, lots of images. But when it comes to face recognition softwares, you have one image. Let's say you have one image. The next image that you get, okay, you have to match whether these two are same or not. That's why this is different. How it is different, you see, previously, when you have this classification task, you are memorizing what a dog looks like, what a cat looks like. And when you try to memorize something, you need lots of examples, lots of samples. So in classification task, you have memorizing, you have lots of parameters to learn, lots of weights to learn to actually classify cats. So when it comes to memorizing, you have lots of different samples given so that you can actually memorize that properly. But in facial recognition, when you have, we are no longer memorizing. আমাদের memory আছে? No, we are not trying to memorize it. Rather, we are trying to compare it. That's why it gets different. We are trying to compare this one with this one. Okay. So basically, what we do, so the CNN is trained like this way that, let's say this is the stored image, and this is the new image that you have. The CNN tries to learn from the face some of the features, facial recognition. This is like, if you call it face embedding, let's say 512 features. Then whenever you have a new image through the CCTV, you also try to learn the face embedding, also 512 features. Then you match these ones with these ones. This is called similarity matching. How much similar this face with this one? Okay, if you find that this face with this one is 70% similar, then you say, okay, this person and this person are the same person. If you find this is 30% similar, you say, no, they are not the same person. So with all the images that you have stored, you try to match these ones with all of them. Some will be 20%, some will be 25, some will be 70, some will be 75. The highest that you get, you say, this person is actually that person. Okay. Again, you are not memorizing what these actually images are or what this face are. Rather, you are comparing from one image with another. Okay. And the CNS algorithm that is actually used, it is trained to work that way. Okay. The algorithm is trained to work exactly that way. We'll talk about it a little bit later. Is the concept clear? Basically, the idea.
Yes, sir.
Now, so the algorithm that is actually used here, so these
স্যার
are,
ফেস এমবেডিং এর জিনিসটা আরেকবার বলেন।
হ্যাঁ বুঝিনি,
স্যার ফেস এমবেডিং যেটা বলা হয়েছিল।
হ্যাঁ ফেস এমবেডিং আসতেছি বলতেছি। So the algorithm that is actually used for this task, these are the algorithms: few shot learning, one shot learning, and zero shot learning. So the one that we actually showed earlier, face recognition, that is one shot learning, right? One shot learning means you only have one shot available. Okay. Just one shot of the one image available, you have to match one image with another. So this is called one shot learning. In few shot learning, you have few samples available to match. In zero shot learning, you don't have any object, any available. Then how it works? Let's see. Acha. In few shot learning, you have say multiple examples available. In one shot, you have only one. In zero shot, you don't have anything. Then how it is used or how it works? Acha. Let's think of it like this way. In few shot or one shot learning, so this is a squirrel. Okay. Now, in one shot learning, you see, you are not memorizing what a squirrel looks like. Rather, you are trying to match whether this squirrel looks like this, whether it looks like this, what is the similarity of these two images. Okay. The task is different. Here, the task is similarity matching. Similar, how much similar? So you see 0.2, similar is 0.9, this is 0.7. So you try to match the similarity, and the one that gives you the highest similarity, you say this is this. So this is the idea of one shot learning. You are matching the similarity. Okay. That's your one shot learning. Now let's see. So one of the application of one-shot learning is facial recognition that you have seen. Now, তাহলে zero shot learning টা কি জিনিস? Look at this example. You see, your model is trained on images like cat, dog, horse, etc. But it has never seen a zebra. Okay. But zebra is to the algorithm, it's like a new object. The concept of zero shot learning is that it will not be able to identify the category, but it will be able to say this is horse-like because zebra is similar to horse, plus it has some black and white stripes. So that's the core idea. Okay, you have not seen some object, but you have to try to identify that, match it with something that you already know. So why it is used? So let's say, for instance, this one, never seen a game, like a unicorn. You have never seen. So what is this? This is like a horse with some like what wings and two horns. So why it is used, you can say why it is used, robotics. So for instance, in robots, like robots, household robots, especially in established countries, you have household robots. They have to interact with new objects they have never seen before. Okay, you cannot always give it or make it learn all the objects that you've seen. So there will be some new objects, and it needs to generalize to new objects. So that means you have to, whenever it finds a new objects, it tries to match what this is similar with. আমি কোন জিনিসটার সাথে জানি যেটার সাথে এটা actually similar. So that's what zero shot learning means. You don't know the exact thing, but you try to match it with something that you already know. Okay, that's the idea of zero shot learning. Is it clear? Any question? The difference clear? Zero shot, one shot, few shot. Okay,
Yes, sir.
let's move on. স্টুডেন্ট এত কম কেন? মাত্র 30 জন। আচ্ছা, in one shot learning, so basically to match two images like Brad Pitt with Brad Pitt and say whether they are similar or not. That's the one shot idea. In zero shot, see, like this, knowledge transfer. Okay, zebra is like horse-like, strip, black and white strips like this. Acha. Now, how it is actually trained to do that? That's one of the question. How the algorithm is actually trained to do this. So training for few shot, this kind of learning is different than standard deep learning. So model learns to generalize new classes rather than memorizing. Okay, let's see. The goal is to similarity between samples. So the algorithm, the model that is trained to identify similarity, not pattern. Okay, let's move on. Achha. So the algorithm that is used, that is called triplet loss. What is triplet loss? You see, in triplet loss, you will have an anchor image. So this is the anchor image. A positive image, that means the same image of the same person. Negative image of a different person. When the model is trained, it tries to learn what makes these two images similar, what makes this image as this image, this image and this image dissimilar. Okay, so this idea, this is called a Siamese network. Okay, the Siamese network uses a triplet loss. So you see 1 and 1, anchor and positive. So the algorithm learns to identify similarity between object, also the dissimilarity between objects. Okay, so that is the basic idea how this network is trained. So in face embedding, what we actually said earlier, so the embeddings is this. Okay, these vectors, these values. So when the algorithm is trained, it is trained like this. How this one or why, based on which features this one and this one is similar, and based on which features this one and this one is dissimilar. That is the two different types of word embeddings that is there. Similarly, why this image is similar to this one, why this image is dissimilar to this one. These are the embeddings that you have, two different embeddings. So now when you have a new image, you try to match whether this embedding is similar to this similarity or the dissimilar, which one this is actually match more. So based on this, you calculate the triplet loss and you try to identify whether they are close to similar or dissimilar. Whichever is closer, you predict it on that class. Is it clear? Question clear? Any question? Acha, if you don't understand, try to look into it a little bit more depth. একটু সার্চ দিয়ে দেখিও তাহলে বুঝবা। আচ্ছা, image synthesis. Synthesis is basically generating new images. Previously, when you had tabular data, we use SMOT to generate new instances. In synthesis, when it comes to images, you have other algorithms. One is called GAN. generative adversarial networks. ওই যে আমরা পড়ছিলাম, we had studied adversarial search, the same concept. Okay, a similar concept that is used here, and diffusion models that is more recently. Okay, they are actually used to generate new images. আচ্ছা, some of the recent addition to computer vision like vision transformer. So previously we have said about CNS, convolutional neural network. So after 2019, convolutional neural network is very popular. Then after 2020, vision transformer actually was introduced. Okay, and vision transformers actually try more or less outperform CNNs, performs even better. And these are the like the new models in computer vision. Then diffusion model অনেক বেশি ইউজ হয়. So the things that you are using, image generation, using creating new images from different characteristics, like, so all of those things actually done by diffusion models. Vision language is combining image and text. Okay, acha. So this is your any question up to now? কারো কোনো question? Okay, if not, so this is the end of the class. Okay, so write your student ID in the chat.